Okay, so what is a domain? Domain are basically all the values of x that can be plugged into the function. So normally with functions like these, we see a specific value of x that cannot be plugged into a function. Why? Because if you plug in this value of x, what happens is that the denominator becomes undefined. The denominator becomes 0, which leads to the entire function becoming undefined. Okay, so we're gonna look at how the range turns out to be depending on the domain. Okay, so we're going to look into something called restricted domain. Like sometimes you will notice that the question will restrict you and will only allow you to plug in a certain range of values of x. Okay, so that's what we call restricted domain. I mean, that's not an official name, but when you have a certain restriction as to the domain, we can call it restricted domain. Now, just to further understand the idea of domain, because we didn't do enough examples in the last class, I'm just going to do one more. Normally with square root functions, when is a square root function defined? Like how can you make sure that a square root function is defined? You will make sure that whatever is inside the square root is positive. Okay, so you'll have to make sure that whatever is inside the square root is positive. And how do I make sure that whatever is inside the square root is positive? You will say that x is greater than or equal to 0. So that's why with functions like these, with square root functions, you will often notice no, you didn't miss anything. We're just starting. With questions like these, you will often notice that they will give you a certain domain which keep the whatever's inside the square root positive. Okay. Now, here's I'm gonna give you guys not. I mean, you guys won't be solving it. We'll solve them together, and the idea would be to pick up a few patterns. Okay, so from the following questions, we're gonna do at least 2-3 examples where we will find the domain, and don't just focus on the question. I want you guys to focus on a pattern. So here's the first question. And the question is that we have to find the range. So find the range of f of x, which is equal to 3x minus 1 for the following domains. Okay, a lot of times people just ask for shortcuts. Okay, in functions, let me tell you, there is no shortcut. If you want to get it right and if you want to be confident about what you're doing, in that case, it's best that you do it the longer way so that it's clear to you and also clear to the examiner. So let's say in the first part, this is what the domain is, that x belongs to the set of all real values. And then in part B, the domain is that x is greater than or equal to -2, lesser than or equal to 3. So this is what I was talking about when I said that sometimes we'll have a certain restriction on the domain. So this can be termed as a restricted domain. That means you can only plug in a certain range of values of x. Now, we all know what a straight line looks like. We've all done coordinate geometry. Even if you guys haven't done coordinate geometry, you guys should know what a straight line looks like. But just to be 100% sure, this is the graph of f of x equals to 3x minus 1. This is a line which has gradient +3 and y-intercept -1. Now, if there is no restriction on x, meaning that you can plug in a value as large as possible or as small as possible, meaning you can plug in positive infinity, you can plug in negative infinity, there is no restriction. What do you think the range is going to be? So imagine that you plugged in a very large value of x and imagine that you plugged in a very small value of x. What do you think the range is going to be? All real numbers. Okay. Anyone else? Or anyone who disagrees with what Saad is saying? So according to Saad, the range should be all real numbers. -7, 8. Achha, I'm talking about part A right now. Fajr, I'm talking about part A right now. You're giving me the answer to part B. But part A, there is no restriction. That means as far as part A is concerned, this line is going to go on forever. And this line is going to go down forever. So there is no restriction. That means the range will reach pretty much every real value there is. It will reach 100, 200, 300, 500, infinity, and negative infinity, and everything in between. So that means as far as the range is concerned for the first part, it's going to be f of x belongs to the set of all real values. Okay, or you can say f of x is greater than negative infinity and lesser than positive infinity. Basically from negative infinity to positive infinity. Okay. Now, in part B, however, in part B, we are restricting ourselves. How are we restricting ourselves? We're saying that, you know what? You're only allowed to plug in the values of x that are in between -2 and 3. Okay, you can plug in -2, you can plug in 3 and everything in between, but that's it. Not a value lesser than -2 and not a value greater than 3. So that means we are only looking at this part of the graph. We are looking at this part of the graph that I'm highlighting using the color yellow. So if I'm only looking at this part of the graph, that means I'm not looking at this part. This is the part of the graph that we can see, not more than 3 and not less than -2. What do you think the range will be now? What do you think the range will be now? Question for you guys. What will be the range for this domain? Fajr, if you can also just fine tune your answer a little. The values that you've given are correct, but if you can fine tune your answers a little. So here's what we can do. We can see that's correct. We can see that in between these two values, our graph is constantly increasing. That means if I plug in one end of the domain, if I plug in -2, I will get the least value. If I plug in 3, I will get the greatest value. Okay, so the least value, as we all can see, is -7. Okay, that's what we get when we plug in -2. And the greatest value is obtained when we plug in the other end, which is 3. And what's the corresponding value at 3? That's 8. So that means the range is simply going to be -7 to 8. So in this case, we're going to say f of x is greater than or equal to -7, lesser than or equal to 8. Pretty simple, I know. But sir, haven't they given us a range? No, range hoti hai y values. Okay, this is the domain. Domain is the range of x, and when we just say range are basically the y values. They have given us the domain that you can only plug in values of x in between -2 and 3, and now we're seeing that for these values of x, for this domain, what is the range? Yes, so -7 to 8 is the range. If your domain belongs to all real values, how would you figure out the range? Well, we just did. The domain here was all real values. So we observed a pattern. We saw that for as long as x keeps increasing, y also keeps on increasing. There is no limit. And just like that, for as long as x keeps decreasing, y will also keep decreasing. There is no limit. So that means the range will be all real values. Is it a rule? No. There is no such rule. There is no such rule. Hang in there. Hang in there. Okay. Now, let's do another example. I want you guys to pick up a pattern. Don't make a standard rule just yet. Okay, I'm warning you guys to not make a standard rule. Ye mat samajhna ki if there is the range domain is all real values, that means the range will be all real values. In fact, you will see why that's not the case from this example. So I don't get why we ignore all the values above 8, because when do you obtain all the values above 8? All the values above 8 will be obtained when you plug in a value greater than 3. Can you plug in a value greater than 3? Yes or no? Looking at the domain, can you plug in the values? Of course not. It's like I'm only showing you this part of the straight line. So if you're only looking at this part of the straight line, you would notice that the range of this part is from -7 to 8. Okay, that's why. So I hope that answers your question. Don't worry about any what ifs at the moment, because the range of what ifs is endless. So let's focus on, let's take one question at a time. So find the range of f of x equals to 2 power x for the following domain. Part A, x belongs to the set of all real values. Part B, once again, we're going to restrict ourselves slightly, and we're going to do it from -2 to 3. Now, I'm sure you guys know what an exponential curve looks like. Can 2 power x ever be negative? Can you plug in a value of x, which if I plug in, I get a negative result? Think about it. What value of x should I plug in so that I get a negative result? Possible here? Is it possible that you raise a positive number to a certain power and you get a negative result? No. I mean, try it out. All right, Subhan, try it out. Tell me what value of x gives us a negative result. Try it out. as in use your calculator and tell me this specific value will give us a negative result. Is it possible? You realize it's not possible actually. Okay, and it's also not possible to turn it into 0. You cannot raise a positive integer to any power and have the result come out to be 0. Yes, it's going to get smaller and smaller, but it's not going to be 0. So to be precise, this is what the graph of 2 power x looks like. Okay, this is what the graph of 2 power x looks like. Now, अब हम इसको जरा डेस्मॉस पे भी देखते हैं, because I want to show you, this is only a part of it, but I want to show you guys something. So here it is. Y equals to 2 raised to the power of x. Now, yes, Fajr, your answer is correct. Good job. Now, as far as the maximum value is concerned, there is no limit. X जैसे जैसे बढ़ता रहेगा, आप देख सकते हैं यहाँ पे x बढ़ रहा है, ठीक है, y भी बढ़ता रहेगा. There is no limit. If I zoom out, you can see that there is no limit. It will just keep on going. But as far as the minimum y value is concerned, okay, let's see what happens as x keeps on decreasing. So you can see x is decreasing, okay, and what's happening to the graph is that if I zoom in, you will notice that it's getting closer and closer to 0. It's not actually 0, but it's getting closer and closer to 0. So that means it will never actually be even equal to 0, no matter asymptote. Yes. Now we're going to formally deal with asymptotes. Okay, we're going to formally deal with asymptotes later on when we're doing graphs of exponential and logarithmic functions. Okay. But right now, what we have is we have ourselves a horizontal asymptote. अच्छा, अब ये horizontal asymptote कहाँ पे है? ये horizontal asymptote है y equals to 0. Okay, asymptotes are basically, we've done trigonometric curves. Asymptotes are basically lines that a curve approaches, but it never touches or even cuts it. So we have ourselves a horizontal asymptote, and the horizontal asymptote is y equals to 0. Okay, so that means this graph gets closer and closer to 0, but is never actually equal to 0. So keeping this graph in mind, can you now tell me, although Fajr has already answered the question, but can you now make sense why the range of this graph will be f of x is greater than 0? Okay, we're not even going to say f of x is greater than or equal to 0. We're going to say f of x is greater than 0, and that's it. Okay, so if you were thinking कि हम बोलेंगे f of x is greater than or equal to 0, or if you're going to say f of x belongs to the set of all real values, that's not correct. Just because the domain is all real values does not mean that the range will also be all real values. Why? Because sometimes, naturally, the curves have a certain range, as in they have a certain minimum value, they have a certain maximum value. And we've done it. I mean, those of you who have been with me since August would know that there are some curves which naturally have a minimum value. What are those curves? Let's see if you guys remember. There are some curves that naturally have a minimum or a maximum value. Quadratic, that's correct. Okay, so they by nature have a minimum or a maximum value, not necessarily cubic. Cubic ki wo, yes, there are turning points which are either maximum or minimum in nature, but wo unki maximum या minimum value नहीं होती. Quadratic is the correct answer basically. Okay, and even trigonometric. Now cos has a maximum value, it has a minimum value, so yeah, trigonometric curves as well. Now, so part A, I hope is clear. The range will be f of x is greater than 0. Now part B. Part B, we have restricted ourselves from -2 to 3. So that means I'll highlight the part of the curve that you're now allowed to look at. You're only allowed to look at this part of the curve from -2 to 3. Now आपने इससे आगे देखना है, 3 से आगे देखना है, ना आपने 3 से पीछे देखना है. Now, if this is the case, what will you say is the range? Let's see. So we're going to plug in the extreme points, as in we're going to plug in 3, we're going to plug in -2, and we're going to find out the corresponding y values. So if I plug in 3, the corresponding y value is 8. If I plug in -2, I can't read it from the graph. Actually, you can read it from the graph, but to get an exact value, just plug it in the equation, and you will notice that if you plug in -2, you get 0.25. That's correct. So the range will be the following. F of x is greater than or equal to 1/4, lesser than or equal to 8. All right, any questions so far? Yes or no? Okay, great. Now we're going to do two more examples, and then we are going to establish a standard rule. Sir, the graph will always be given. No. The graph will not always be given. Okay, we will have to make it ourselves. Like usually you'll have cubic, usually you'll have quadratic or trigonometric. So, देखो, I'll tell you how to figure it out without the graph. Do we already know what an exponential graph looks like? We already know what an exponential graph looks like, right? We already know what a quadratic graph looks like. We already know what a cubic graph looks like. So it's always a good idea to draw a rough sketch. Okay, it's always a good idea to draw a rough sketch. और वो भी मैं explain करूंगा आपको क्यों या किस केस में आपको rough sketch बनाना चाहिए. In some cases you won't have to, in some cases you will have to. Okay, so just bear with me. It's one of those topics that comes together in the end, as in not by the end of the chapter, but by the end of the concept. Okay, so don't worry about it. Now, let's say the question says that find the range of f of x, which is equal to cos x, for the following domains. Okay, and the first part is from 0 to 360, and then part B is 0 to 180. Okay, now this is an interesting example because this example ki madad se, with the help of this example, we're going to learn a very important concept. Okay, so keep your eyes and ears open. We all know what the graph of cost looks like. Okay, so here is 1, here is -1, here is 360, here is 180, here's 90, here's 270. So let's join all the points, make ourselves a nice and smooth curve. There we go. Okay, now, what was the approach that we took earlier? The approach that we took earlier was we plugged in -2, we got a certain y value. We plugged in 3, we got a certain y value, and then we gave our answer in range form. We plugged in -2, we got a certain y value. We plugged in 3, got a certain y value, gave our answer in range form. Basically, we plugged in extreme values, we got extreme values. Okay, now, let's see if I can do the same over here. Let's plug in one end of the domain, that is 0, which is going to be cos 0, which is equal to 1. Let's plug in the other end of the domain, 360, which is going to be cos 360, and that's going to be 1 as well. So can I say f of x is greater than or equal to -1? Sorry, greater than or equal to 1 and lesser than or equal to 1. Can I say this? Yes or no? Of course not. Of course not. Why? Because looking at the graph, it doesn't even make sense. कि हम कहें कि भाई 1 से 1 तक range है. It doesn't make sense. And we have the graph in front of us. We have the graph in front of us, and we can see the range is not from 1 to 1. So that means this is absolutely wrong. Okay, this is absolutely wrong. The correct range would be f of x is greater than or equal to -1, lesser than or equal to 1. Okay, can we all agree that this is the correct range? Don't worry about how will we know what we have to do. Abhi uska jawab mil jayega. But I hope we all can agree that this is the correct range. Okay, now, here's a question for you guys. Okay, I want you guys to think about it. How come we plugged in the endpoints in this question and we got the range correctly? And we plugged in the endpoints in this question. When I say endpoints, I mean domain key extreme values. We got the range correctly. So how come we got away in this question, but we don't get away in this question? Why is that? Very good. Moiz, spot on. Because the first two, if you think about it, how would you classify this? If I ask you to classify this function, in what category would you put it? You would put it as a one-to-one function. Okay. And what's so special about one-to-one functions? If you go back, one-to-one functions हमेशा या तो increase होते हैं या हमेशा decrease होते हैं. Okay. One-to-one functions are either always increasing or always decreasing. Let me show you guys. So this is a one-to-one function, correct? What is it doing? it's always increasing. This is also a one-to-one function. Why? Because it's always decreasing. Okay, so this is also another way to test whether it's a one-to-one function or not. Let's take another example. Let's say we have y is equals to minus 5x plus 1. So this is a straight line. We all know straight lines are one-to-one function, but we can see that this is always decreasing. And this is also always decreasing. If let's say we have y is equals to 3 to the power of x, this is also a one-to-one function. Notice that it is always increasing. So because a one-to-one function is always increasing or always decreasing, what happens if you plug in the endpoints of the domain? You get the extreme values. Like for example, here, because this function is always increasing, if I plug in minus 2, I get the least value. And if I plug in 3, I get the greatest value. Because this function is always increasing, if I plug in minus 2, I get the least value. And if I plug in 3, I get the greatest value. सबको समझ आ रहा है? Because रट्टे नहीं लगाने हमने. We have to make sure that we understand the concept. Only then will you guys be able to solve domain and range questions. So make sure that this is absolutely clear to you. If it's not, please ask right now, because if you don't get this concept, you won't be able to solve domain and range questions, and you're just going to keep struggling over and over again. And a lot of people don't pay attention to this. They don't pay attention to how important this concept is. So the reason why I'll repeat, the reason why we get away in this and in this is because these two functions are constantly increasing. Okay, that's why we get away with it. So, sir, for one-to-one, we can plug in. Yes, we're just going to write that down. For one-to-one, we can plug in the endpoints and find out the answer. For many to one, we can't do that. अच्छा, अब एक interesting चीज है. Okay, so I hope the concept is clear. Because one-to-one is either always increasing or always decreasing, we can plug in the endpoints of the domain and find the range. But interestingly, if I apply that concept here, meaning if I do cos 0, I get 1. And if I do cos 180, I get minus 1. And then if I write down the range, I get the correct answer. अब ये क्या हो गया? अभी हमने पूरा एक standard rule बनाया कि that only works for one-to-one function where you plug in the extreme values. But now, even though we have a many-to-one function, but we plugged in the extreme values and we still got the correct answer. अब क्या करें? Anyone who can explain to me why this works? It's now a one-to-one function. That is correct, because from 0 to 180, what is the function doing? Is it increasing or is it decreasing from 0 to 180? What would you say? It's decreasing, and that's it. If let's say we apply the vertical line test, we apply the horizontal line test over here from only 0 to 180, you will notice that it only cuts it once, which means it's at least this part of the function is a one-to-one function. Okay, at least this part of the function is a one-to-one function, and just this part in isolation, that means if I wipe off the previous half of the curve, it becomes a one-to-one function. And similarly, if I wipe off the second half of the curve, it becomes a one-to-one function. And this is a concept that we're going to learn later on when we're doing inverse, that how should we alter the range, the domain, sorry, so that it becomes a one-to-one function. Okay, so the reason why it works is because it's a one-to-one function. So I'm going to write that down. I'm going to make an important note, and that is f of x for x is greater than 0, greater than or equal to 0, lesser than 180 is a one-to-one function. Okay, now some standard rules coming. Part 1. A one-to-one function is either always increasing or decreasing, but not both. Okay, so it's always increasing or always decreasing, but it's not doing both. So that means it could look something like this, or it could look something like this. You can see this is constantly decreasing. You can see this is constantly increasing. On the other hand, a many-to-one function a many-to-one function will be both. Okay, and what do I mean by both? Meaning it will be increasing and decreasing under a given domain. So if a function is doing both, increasing and decreasing under a given domain, that means it's a many-to-one function. Okay, so for example, cubic curves, something like this, or even quadratic curves. Quadratic curves are a classic example of many-to-one functions. Okay, now, any questions so far? If yes, feel free to ask. If not, then we're going to do a question where you will be asked to find the range of a quadratic curve. Find, yeah, sure I can. I'll scroll up, take a good look. Let me know when you're done. What if the gradient is 0? So that means you have a horizontal line, then it's not a function. It's not a function because, sorry, it's not increasing or decreasing. It's a function, but it's a constant function. It's neither increasing nor decreasing. So in that case, उसकी कोई range नहीं होगी, उसकी एक fixed y value होगी. So how do we find range when it's like cos greater than 0 but less than 360? Okay, so how do we find out the range if it's greater than 0 and less than 360? So the standard rule, which I was going to write, is this, that if it's a one-to-one function, then plug in the extreme points, find the range. If, however, it's a many-to-one function, meaning a trigonometric, a cubic, a quadratic, in that case, the best thing to do is to make a graph. Okay, in that case, the best thing to do is to make a rough sketch, which should not take you more than a minute. And you will realize, when we're solving past paper questions, that the questions are designed in such a way कि वो एक part में आपसे sketch बनवाएगा, फिर अगले part में आपसे उसकी range निकलवाएगा. So you'll already have all the necessary information to find out the range. And even if, let's say, the question hasn't asked you to make a sketch, then in that case also, it's in your best interest to first make a sketch and then answer the question. Okay, so I hope you're done copying. Now let's move on to another very important example. You're welcome. Find the value of f of x equals x minus 2, the whole thing square, plus 3 for the following domains. अच्छा, अब आपने करना क्या है? You have to notice that, if this was a past paper question, then this question would be structured like this. It would first ask you to convert it into completed square form. Then it might ask you to write down the coordinates of the turning point. So basically, it would set you up to find out the range. Okay, but this is not a past paper question, so that's why I've already given it to you in completed square form to save some time. And here's part C, that x is greater than or equal to 3, lesser than or equal to 5. Now, how will I figure out if this is a one-to-one function or a many-to-one function? Now, by default, what is a quadratic function? By default, is it a one-to-one? It's a many-to-one. Yes, it's a many-to-one function. Okay, so by default, it's a many-to-one function, but it may be possible that under a certain domain, it becomes a one-to-one function. Okay, it may be possible, but how will we know? Well, your safest bet is to make a rough sketch. And the only thing, honestly, that you have to take care of when you're making a rough sketch is the turning point. That's it. Okay, because that's something that's important in a quadratic curve, especially when you're finding out the range. And what do you think will be the coordinates of the turning point? Let's see if you guys remember. Quadratics, 2, 3. That's correct. So here's 1, here's 2. Okay, and let's say somewhere over here is 3. Okay, it's a rough sketch. Remember, it's a rough sketch. Don't waste a lot of time trying to get it exactly right. It's just a very, very rough sketch where all you have to make sure is you get the nature right, of course. I mean, I hope you don't end up making this as a maximum curve. So get the nature right and get the turning point right, and that's it. You're good. So here's y and here's x. Okay. Now, so the question was that x, in the first part, x belongs to the set of all real values. What do you think? If x belongs to the set of all real values, what do you think will be the range? Can I say f of x also belongs to the set of all real values? Can I say the range is all real values? What do you think? Of course not, because a quadratic curve by nature has a minimum value. This is a minimum curve, so by default, it will have a minimum value. What is that minimum value? That is correct. It's going to be greater than or equal to 3. Good job, Sana. So the range for the first part would be greater than or equal to 3. Okay, I hope nobody disagrees with that. If you do, feel free to speak up. This is the least value. All the other y values, as you can see, are greater than 3. Okay, so therefore the range is greater than or equal to 3. Okay, now part B. Part B is from -2 to 3. So let's assume that -2 is somewhere over here, perhaps. Okay. So let's find out the corresponding y value at -2. We're going to have to make some adjustments. So if I find out the corresponding y value at -2, which can be found by simply plugging -2 into the equation of the curve. So -2 will be -4, square of which is 16. 16 plus 3 is equals to 19. So that means f of -2 is equals to 19. That means this corresponding y value that you're looking at is 19. Then let's plug in 3. So if I plug in 3, 3 minus 2 is 1, square of which is also 1, 1 plus 3 is 4. So that means 3, which is going to be somewhere over here, the corresponding y value at this point is 4. So can I say, listen to my question very carefully. Can I say that the range is from 4 to 19? Can I say that? Of course not. Why? Because in between these two values, our function dips slightly. Okay, it goes further down. So that means you cannot simply plug in the two endpoints and find out the range. If you do that, मैं यहाँ पे लिख देता हूँ कि for part B, you can't simply say that f of x is greater than or equal to 4 and lesser than or equal to 19. This is wrong. What will be the correct answer? What do you think will be the correct answer? That is correct. 3 and 19. Because we can see what the minimum value is. We can eyeball it. And between -2 and 3, the greater value is obtained by plugging in 3, which is 19. So that means the correct range would be f of x is greater than or equal to 3, lesser than or equal to 19. Okay, Shumaim, देखो. Let's say मैं आपसे कहूँ कि आप जो है ना सिर्फ इस part of the curve को देख सकते हैं. Okay, you cannot look left and right. Just this part. Now, as per this part of the curve, you think it would be appropriate to say that the least value of this part of the curve is 4 and the greatest value of this part of the curve is 19? Look at the curve and tell me if that makes sense. Of course not. Why? Because we're looking at the curve and we can see कि भाई ये तो और नीचे जा रहा है, ये तो 3 पे भी जा रहा है. Why? Because 3 is the least y value. So the correct range would be from 3 to 19. Now, if you're wondering how will we know what we have to do, don't worry about that. Okay, do not worry about that. Now, here's the thing. अभी बहुत सारे स्टैंडर्ड रूल्स आ रहे हैं, ठीक है, बहुत सारे नोट्स आ रहे हैं, बहुत सारे स्टैंडर्ड रूल्स आ रहे हैं, बट आपने सिर्फ उनका रट्टा नहीं लगाना, आपने इसको अंडरस्टैंड भी करना, ठीक है. जो सारी हम मेहनत कर रहे हैं इसलिए कर रहे हैं सो दैट वी कैन अंडरस्टैंड इट एंड देन वी कैन स्टिक टू द स्टैंडर्ड रूल. Now, for this part of the curve, from 3 to 5, if I plug in 3, which we already have, we get 4. And if I plug in 5, so 5 minus 2 is 3, 3 squared is 9, 9 plus 3 is 12. For this part of the curve, if I say that f of x is greater than or equal to 4, lesser than or equal to 12, this is correct. This is absolutely correct. Now, why is that? Why is it that this is correct? 3 pe, it's 4. And then if I plug in 5, which is going to be roundabout over here, and if I plug in 5, I get 12, which is going to be somewhere over here. And looking at the graph, we can see that our answer is correct. that for this part of the curve, the range is in fact from 4 to 12. That is correct, because now for this specific part of the domain, it has become a one-to-one function. Okay, or it's always increasing. Okay, so I hope the concept is now clear. Now we're going to write down a couple of notes. So note number 1, in order to find the range of a one-to-one function, in order to find out the range of a one-to-one function, we simply plug in the two endpoints of the domain and give answer in range form. Okay, so for example, in question number 1 and question number 2, you plug in the endpoints and give your answer in range form. All right. Now, key point number 2. In order to find the range of a many-to-one function, we have to make a rough sketch to find maximum / minimum value of before stating the range. So for example, in example number 3 and 4, if we wouldn't have made a sketch, we would have gotten 1 and 1 as our corresponding values. But after making a sketch, we can see that the least value is -1. And here also, we made a sketch. And remember, the only thing we took care of was the fact that this is going to be a minimum curve and the turning point should be spot on. That's it. That's the only thing we took care of. Okay. So if we did that, we could see the minimum value. And then when we were writing down the range, we took that into consideration. अच्छा, अब एक note आप लिख लें. I want you guys to, and I'll write this down also, that if the x coordinate of the turning point of a quadratic curve is somewhere in between the domain, that means it's going to be a many-to-one function. Like for example, here, what's the x coordinate of the turning point? The x coordinate of the turning point is 2. Or 2 in दोनों के बीच में कहीं पे, that means for this part of the domain from -2 to 3, it's going to be a many-to-one function. But if the domain is such that the x coordinate of the turning point is not somewhere in between, it could be in the end, that's all right. But as long as it's not somewhere in between, that means it's going to be a one-to-one function. Okay, does everyone understand? Like for example, if I only give you this part of the curve, it's going to be a one-to-one function. Even if I give you this part of the curve, it's going to be a one-to-one function. Or even if I just allow you to look at this part of the curve up until the x coordinate of the turning point, you would see a one-to-one function. Okay, we're going to write this down also, but I was just explaining it. So another important note, and that is, as long as the x coordinate of turning point is somewhere in between the domain, the function will be a many-to-one function. All right, so I hope you guys aren't getting too bored. Here's the probably the last concept, and that is how to turn a quadratic function, which by default is a many-to-one function, to a one-to-one function. Yes, sir, please. Okay. Yeah, there you go. Yes, that's true. These two notes, they just summarize everything that we have done. Okay. But in order to make sense of the note, you have to look at the examples. Okay, so they're connected. You look at the examples, then you look at the notes, they make sense. If you just look at the notes, they don't make sense. Okay, how to turn, and please, these notes are not just for the sake of explaining, they're for the sake of, so that in case you guys ever forget, you can refer to your notes. And trust me, you will forget. Okay, you will forget. It's not exactly a big deal forgetting, but make sure that if you do forget, you refer to your notes. Okay, I always encourage students to refer to their notes. Why? Because in the process, when you refer to your notes, I know it sounds difficult. You can just message someone and ask, you can message me or message in the group and ask, but मैं अक्सर notes refer करने का stay बोलता हूँ, not because I don't want to respond or something, because when you refer to your notes, you in between, you end up learning a thing or two. You end up looking at something which you didn't originally intend to look at, and you might look at a formula and maybe realize that, oh, I had it memorized. Had it memorized all wrong. This is what the correct formula is. Or you may look at a certain concept and realize that this is something that I had forgotten, so I might as well review it. So that's the whole idea behind referring to your notes, behind me asking you guys again and again to refer to your notes. Anyway, so this is a quadratic curve. Okay, so this is the x coordinate of the turning point. This is the y coordinate of the turning point. So here's h and here is k. Now, what if I ask you to do the following? What if I say that the domain is all real values? So as per this domain, what would you classify this function as? As per this domain, what would you classify this function as? A many-to-one function or a one-to-one function? Okay, there is no restriction on x. You can see the entire curve. So you would classify this as a many-to-one. Okay, but if I say the following, if I say that x is greater than or equal to h, or even if I say x is greater than h, okay, there are no separate rules for greater than or equal to h. Then what would you see? Like, for example, if I only make you look at this part of the curve, you don't know that this is a quadratic curve, you're only looking at this part of the curve, you would think that this is a one-to-one function. Okay, or if let's say I hide the first half of the curve and I only make you look at the second half, you would clearly see this to be a one-to-one function. That's correct. Why? Because it's constantly increasing. Another way to identify a one-to-one function from a many-to-one function is that it's either constantly increasing or constantly decreasing. Now, lastly, if let's say this is the new domain, then what happens? And as per this domain, once again, it becomes a one-to-one function. Why? Because now the function is constantly decreasing. So it's decreasing, 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 decreasing. That means it has now become a one-to-one function. Okay, any questions? If yes, feel free to ask. Okay, now I am going to give you guys some questions to solve. Here. Find the range of each of these functions. Go ahead. In the first part, is it a one-to-one function or a many-to-one function? You don't even have to actually make a sketch to figure that out. What's the x coordinate of the turning point? And then look at the domain, and you'll find the answer to your question, the answer to my question. It's a many-to-one. Are you sure about that? It's a one-to-one. That's correct. Because the domain is greater than or equal to 2, that means if you think about it, so if you have any doubt, remember, ye doubt hai, what's the best way to eliminate doubt? Make a rough sketch. That's it. So what kind of a curve are we talking about? We're talking about a minimum curve, okay, which turns at 2, 5. So that means here's 2, somewhere over here is 5. Notice that I'm least bothered with the scale. मैं बस ऐसे ही roughly एक sketch बना रहा हूँ. Okay, just getting the turning point right. Now, if you look at the domain is x is greater than or equal to 2. That means we're only looking at this part of the curve. And if you're only looking at this part of the curve, it becomes a one-to-one function. Okay. So what would be the range? That is correct, except there's one thing missing. It's going to be greater than or equal to. Okay, greater than or equal to.